Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you.
So now the first question which we are going to learn is what is Kubernetes? Okay. So if you'd like to answer this question, what is Kubernetes? We need to answer these 4 questions. Where did it come from? What does it do? What does the name mean? And why do we have it? Okay.
Okay.
So Kubernetes is born in Kubernetes is born in Google, and the same product got donated to CNCF in 2014, and then it's become open source. Now this product is written in Golang, and the source code you can find at the GitHub. Websites we have kubernetes.io, Slack channels, and Meetups group. So that is the something. Now the next question is where did it come from? So the the idea of the Kubernetes, is coming from the Bog and Omega. So if you look at this picture here, DNA is matching with the Bog and Omega. So now what is a Bog and Omega? So Bog and Omega on which the Google is running their applications. So Kubernetes also can do something like that. Kubernetes can also run your application at the large scale, manage your run applications, container runtime at the large scale. So we can say like DNA is matching, but yeah, in terms of feature of Bog and Omega and Kubernetes, you should not compare. But yeah, so DNA is somewhere close to Bog and Omega. In short, we call it KS. Okay, this is the keyword which has been taken from the Greek word which is called helmsman. So helmsman who steered the ship. So I'll put it in this way. Let's say the size of ship does not matter. Again, whether the size of whether it's a ship size is a small fishing boat or maybe largest aircraft carrier, still it is managed by one person, right? And that person we call it helmsman. So same way, Kubernetes will become a helmsman for your entire data center, large data center where running a application within a container. So that is something that the definition of Kubernetes. So yes, it's born in Google, donated to CNCF in 2014, open source, Apache 2 license. First ever release has happened in the July 2015 and written in Golang and so on and so forth. So this is Kubernetes. Are you comfortable with it, all of you? All of you? Am
Yes,
I
I am.
audible, right? Okay, okay,
Yes,
yeah.
yes, I am.
So now the question is, why do we need it? Why do we need the Kubernetes? So the answer is hidden in this statement. So when you scale the containers beyond the host, that introduce lots of challenges, and that challenges we are going to solve using Kubernetes. Again, if you look at this, when you are using container, uh, you may be running application in the multiple host, but we need to look at it as a one single computer. I mean, whole data center is a single computer. So how and who can help us in this? And that's where the Kubernetes is coming. Okay, so look at this here. This image, you must be comfortable with it, where Docker manages the network, container, images, and data volumes. So, and this Docker you can install in one host, and in the same host you manage a network, container, images, and data volumes. Now, this is the architecture of Docker again. So you do the build through the Docker client or run the images containers, and the Docker host perform the responsibility, and we have a registry also from the images being downloaded and all this thing. So yeah, so I'm assuming that before moving to the Kubernetes, you are a little bit, good in terms of understanding Docker. So this is the Docker architecture. Now the question is, okay, so Docker can manage the container, and you know that Docker is running in the one host. But the question is, let's say I want to run 15 containers, whereas the one host can only handle 3 containers. So what to do? So you'll say run the three container in a 5 different hosts. That's okay. We can run it. We can run 15 container. Each of these, I mean, 5 hosts. Each of these may contain the 3 containers. That's okay. But who's going to manage the multiple hosts? That's the question. So Docker can manage the container in the same host, but Docker cannot manage the container in another host. So how do we do that? Who would manage multiple Docker hosts? That's the first question, right? When you
Yeah.
scale the containers, who should manage it? Now, if you remember the Docker container, you were exposing the port for accessing the container at the node port, host IP and port number. But can you expose to Apache container at the same port of the host? No. Docker has certain limitations. So you cannot expose same container at the host with using the same IP address. Why? Because host you have only one IP address, one network, and because of that you cannot expose. So yeah, you have to expose some other container, some other port, but not the same port. So that's one of the limitation which Docker have it. So in that case, let's say you are running application in data center. So here Docker enforces you to run only one Apache each host. And if I want to run only one Apache each host, what is the use of Docker in that case? Okay. What is the use of container? We can run directly in the host machine only. Why to have a container inside that? So I want to run multiple Apache container in the same host at the same time. Each container should be accessible outside of the host on the same port. How can that be possible? That's a question. So how to load balance multiple container running with the same port in one host? How do we do that? Because you know that load balancer only load balance the container which will have a different IP address, same port number. I repeat, different IP address, same port number. So that's one of the networking challenges which we have with the Docker, and that we need to sort it out. Second thing is, third thing is, let's say we have a 15 container running in a 5 host, and suddenly 2 host is not responding because of some reason, maybe network, hardware, or something like that. So now, are you going to get up at a 3 o'clock in the morning and then fix that problem? Maybe it might not solve the problem immediately. It might take few hours, right? So do we have any mechanism where we need a 15 containers at any given point of the time, but 2 nodes is down? How to do auto healing? That means we need a 15 containers. So let's say 2 node is down, 6 container is down. So immediately within a second, the moment it is down, 6 container, additional container should be created in another host. So 15 should be 15 all the time. So how can we do that? So these are some of the challenge which we have with the Docker, and that's where the Kubernetes can manage it. So let me tell you, Kubernetes can manage the orchestration for container running in the multiple host. Okay. So are you
Okay.
able to understand why we need Kubernetes?
Yeah. I have a
So
fundamental understanding of Kubernetes.
yeah. Now What is the pets versus cattle? So you have to have a little bit of mindset change also. Let me tell you. Let's say where you are in a Docker, then you should be having the mindset of pets. Like, okay, you have one or two pets, you take care of them, play with that. You know, if something goes wrong with the pets, you take it to the doctors, and all this thing you do that. So you have only one and two. Same case with the Docker also. Docker manages the container, and one or two or three containers you have it. You run the container, stop the container, start the container, see the logs of the container, get inside the container, come out of the container. Something goes wrong, you troubleshoot. But in a Kubernetes world, you have to have a mindset of cattle business owner. Cattle business owner means, let's say in a Kubernetes, because you are running the containers at the large scale in the multiple host. So if let's say five containers are not responding, so I don't know what you want it, because five containers should be replaced immediately with the new containers. Repeat, replace with the new container who's should be working. So same concept with the cattle business owner. Let's say cattle business owner is having lots of cattle and they have to deliver the milk of 1,000 liter milks per day to one of the specific customer. Let's say some of the cattle is not functioning properly, so you cannot tell to your client saying that, hey, I have a cattle who's having problem, and I don't want. I'm just taking care of those cattle, and this month or today I will deliver only, let's say, 700 liters of milk only. You cannot say like that. Okay, immediately what you will do, you will replace the cattle with the functioning cattle, and you will deliver 1,000 liters of milk at any given point of time. So the concept of Kubernetes is something similar. Let's say five pod is not working because of some reason, replace with the new pods, and that will be working, and the desire should be actual always. Make sense? So that's kind of business mindset. Mindset you have to build while working with Kubernetes. So when you are learning Kubernetes, main objective to run thousands of containers in a cluster. Okay, so when you are learning Kubernetes, main objective to run thousands of containers in a cluster. If some containers is not working, replace with the new container to make sure actual number of containers must match with the desired number of containers. So who will take care of it? Kubernetes. And that same mindset you have to build in this session also. So what is a Kubernetes? So yeah, I gave you lots of other regions, but here Kubernetes is a container orchestration. Container orchestration means run the container in the multiple host, and Kubernetes can manage it. Okay. Kubernetes is also workload placement. Workload placement means I have hundreds of nodes. Now, how do I decide which node, which container should run, and how many containers should run? I cannot take that call. So who's taking that call? Kubernetes. Kubernetes also provide the infrastructure abstraction, the networking challenges which I said, right? So that is solved by the Kubernetes. So how it is solved? It's internal infrastructure, but it works for you. And each pod, pod and container, I'll talk about it. So each container is accessible. And in the one host, you are running 5 Apache containers, and still it is accessible to the load balancer. So that is something infrastructure abstraction. So that all this problem is solved by Kubernetes. Kubernetes also help you to manage the desired state. Desired state means, let's say you said, hey, I want hundreds of containers. So Kubernetes will make sure that hundreds of containers. Basically, in Kubernetes, we talk about the pod, but right now I'm not complicating the topic. So I'm going with the container because I'm assuming that you know the container very well. So yeah, so you say, hey, I want to run in Kubernetes hundreds of containers, and you just set that, and then you set the desire, and Kubernetes, that's the Kubernetes responsibility to maintain that number of containers at any given point of the time. So Kubernetes is a container orchestrator, workload placement, infrastructure abstraction, and managing the desired state of your need. Okay, so Kubernetes has a helps healing capability, self-healing capabilities also. That means if some of the containers not working, replace with the new container or automatically heal that container. Okay, automated rollback is there, auto scaling is there, automatic scaling, load balancing feature you have inside a Kubernetes itself for the balancing the pod basically. Right now I'm talking about a container. I'm using the keyword container instead of pod, but what is a pod? I'll talk about it. Now, what are the benefits of using Kubernetes? So speed of deployment again, let's say I want hundreds of container pod in 1 second. or 10,000 in 1 second. You have it. You can deploy as many pods or containers in one go. Ability to observe changes quickly. That means when you want to update that any applications, within a second you can update entire infrastructure. Same time you want to roll back, ability to recover quickly. That means let's say your deployment went wrong, so you want to correct it, you can do that. And all the complexity for managing this stuff, it's hidden in the cluster. So basically set your mindset, when you are learning the Kubernetes, set your mindset you are managing the data center where, I repeat, you are managing the data center where you have thousands of node, thousands of server, and each server you want to run a container. So who can manage it? Kubernetes. Are you understanding, all of you?
Yes.
Yeah, on top of it, many other features which is provided by Kubernetes. Again, probably this might not make sense for you, but once you start using it, you will understand that Kubernetes not only can manage the container, but can manage the orchestrations of the storage also, networking orchestrations also, secret and configuration management also. Self-healing capability and automated rollout and rollback, and service discovery is also there, and load balancing. So many features which we have in Kubernetes. So Kubernetes is a perfect platform. It's a platform, okay? Platform for managing entire data centers running in container. Make sense? So this is something
Yeah.
which we have. So yes, definitely Kubernetes will help you to enhance your productivity. Deployments are faster and very simple, lower overhead, improvement in security, increase in portability and immutability. So Kubernetes is moving fast, so every day we have some changes. So the best way to learn the Kubernetes is to be in line with the Kubernetes. Every day you do something with it, learn something, and that's how. Because there are so many releases which is happening, and so many changes which is happening. So far, what we understood what is Kubernetes and why do we need it. These are the two questions I try to answer it. Are you comfortable with it?
Yes, I am.
Okay, so now next question which I'm going to cover, and that is why, how Kubernetes works, basically architecture. So where is the slide? Here it is. So architecture. So let's try to understand the architecture. So how Kubernetes works. So this is a very important topic, and this you have to understood. Okay. So some of the slides I just skip it because it's part of microservices, which I just don't want to confuse you with the too many topics. So dedicated to Kubernetes. So so when you look at the Kubernetes architecture, so you have a Kubernetes cluster. Okay, what do we call it? Kubernetes cluster. Now this Kubernetes cluster, primarily you have a two kind of nodes. Okay, one node which is acting like a master, another node which is acting like a worker. Okay, I repeat, in a Kubernetes cluster, you have a different nodes, multiple nodes you have, multiple server you have. If this node can be virtual machine or physical machine, nowadays it's all about the virtual machines only. Whether this virtual machine can be created on AWS, Azure, or Google Cloud does not matter. So, but this we call it a node, or roles are different. Okay, so some of the nodes will perform like a master, some of the nodes will perform like a node master worker. Okay, so now you can take this word as like master and worker in a real world also. So master who manage the worker, and worker who's doing the real work, and master is been managed by someone very specific one, that's you. Okay, so look at the package which you develop, and this package will contain the your desire, what you want from Kubernetes. Remember that Kubernetes has a lots of features, right? So for example, I'll put it in this way. AWS has lots of features. What do you want from AWS? So you say, hey AWS, give me a virtual machine, give me storage, give me security, give me a PVC, give me BPC, not PVC, BPC, give me IAM, give me networking, give me security, give me load balancing. So all these things you ask AWS, and AWS is giving it to you. Same way, Kubernetes also providing a similar services actually. So you need to ask, you need to put it in YAML file, okay, in YAML file, and that YAML file sent to master, and master will perform everything and with the help of you know worker. Are you understanding?
Yes.
Great.
So I do have a question.
Yes, please.
So when you actually do actually deploy a cluster, so how do you actually differentiate between a master and a worker?
Yeah. So that's the question I'm going to answer in some time, few
Oh,
minutes.
okay.
Yeah. Okay. So now master who's in charge of the cluster. Okay, and worker who's doing the real work, and then you control the master. So that means you control the whole data centers basically. So that is something we have. Now here you have to look at it very carefully. I've been talking about container, but actually you know what? In Kubernetes we don't run the container directly. Okay, so we run the pod. If you look at the image very carefully, we have a pod which is located in the worker, and inside a pod you have a container. So now you must be having a question: what is a pod? See, I'm not going to answer right now what is a pod, but at least one thing is for sure: the application runs in a container, and in this architecture, container is inside a pod, and pod you have in the worker. Make sense? Correct now?
Yeah, okay.
Yeah. So pod contain containers. Container is coming from the image, Docker image, and that contains your application. So basically, yeah, pod will discuss in some time, but not now. So now
Okay.
let's try. So now let's try to focus on the master server. This is the one. Okay. What is the component we have? So now let me tell you here. Master server has to be in a Linux. Master server, the one which you configure, has to be in a Linux. Okay, it can be any Linux 64-bit. It has to be Linux. But you know what? Worker can be Linux and Windows. Right now, this image is not of the Windows right now, but you can think of it because Windows support has started from the Windows 2019 plus. Okay, so worker can be in Windows also, Linux also, but master has to be Linux 64-bit, any version of it. Okay,
Okay, quick question.
yeah.
So what happens and if you actually have a Docker image that's actually running on the Windows framework? Because you said that the master has to be Linux. So how do you differentiate with a Windows framework or image?
So you forgot that one thing. Actually, the all this container is running in the worker, not in the master.
Oh, okay,
Your
okay.
application is running in your worker, and Windows container will run on the Windows worker. Linux container will work in the Linux worker. Make sense?
Yeah, okay.
Yeah.
Can would there actually be a communication issue for a Windows master and a Linux
No,
master?
no. These all are API calls, so no communication issues. Kubelet, which is a agent, which has to be in Windows machine and Linux machine, which I'm going to talk about in 5 minutes.
Okay.
Yeah. So now master server has to be Linux. Worker server can be Linux as well as Windows. Now, the question you should ask: how do I identify which is a master? So basically, in order to see in a data center, you have hundreds of server. When you set up a network in data center, let's say VPC and all, inside that you can run a multiple server, 1, 250, 200 VMs you can run it. But some VMs is acting like a master and some VM is acting like a worker. So how come? What made them to act like a master and what made them to act like a worker? So that is an important question. So in order to act them like a master, that VM will start acting like a master, which manages the entire cluster. So for that, you have to install four software, major four software. Though there are few more, but we are discussing four software. Okay. So which are the software that we'll discuss? So look at this image, very simple image. Master, which has to be in Linux. Okay, 64-bit. Master has a four component which make them a master. Now master manages the worker. Worker can be Linux or Windows. And if you look at the left side, worker have a pod, which I said I will discuss with you in a little bit of time. But worker have a pod, and inside that pod, if you look at it, you have a two containers. Right side, if you look at it, you have one pod each containers, and multiple pod you have it. So what I'm
Okay.
trying to say here, think about it in this way: worker have a pod, you may have a one pod or multiple pod, and each pod you may have a single container or multiple container. Yes, What is a pod? Still we are trying to figure it out. But when you run container in a worker node, then you run in form of pod. And pod, you may run multiple pod in a one node, and each pod you may have a single or multiple containers. That is the scenario. Okay, will you remember this statement?
I will.
Great. So now the question is, how can we convert one particular VM, virtual server or node, and act like a master? So for that, I said you have to install four primary software you need to install in Kubernetes. In the node. So now which software? So the first software, which is called API server. Mind it, let's try to break it down. API server. That means this particular software manages all the API which Kubernetes has it. I repeat, Kubernetes has hundreds of functionality, but in form of what? API. Now the question is, who manages all the API? API server. So that means if you want to ask anything to the Kubernetes, you will ask Kubernetes API server. So API server is a front end to the control plane. Control plane means the master server. We also call it a control plane. Okay. So that is something which we have. Okay. Now this API server exposes, how can you reach out to this API server? So it's a REST API, okay? HTTPS, you can reach out to this. Now, if you want to send a request to API server, how do you send it? So you have to send in a JSON format, okay? So we write a YAML, convert it to JSON automatically, and then it receives in a JSON format. In fact, any API, they receive in the JSON format. So this is the API server. For example, I'll put it in this way. There is an office, okay, and if you want to send any communication to the office, where to report first? Reception, right? Correct now? And reception will guide us like where to go and what to do and all kind of things. Access will be given by reception itself. Correct now?
The gatekeeper.
Yeah, gatekeeper kind of thing. So same way, master server, you have API server which is responsible for all the features available in the Kubernetes cluster. So if you want to send any communications, let me tell you, from outside or inside, you have to talk to API server. So if you look at this here, other component of API master server is talking to API server only, internal component. Okay, so this is the API server. One software has to be installed in the master store so that node will behave like a master. Now next, what are the other software we need? So there is a database. We have written cluster stored, but this is the database. Now you'll say, okay, database for what? So let me tell you, you send a lot of requests to API server. That has to be stored, right, somewhere. And in fact, internal component also talk and communicate lots of other stuff like actual state, desired state, and all stuff like that. So they need to be stored somewhere, right? Some persistent storage, some permanent storage we needed where we can store all the data of the clusters, your request, and actual or desire, whatever it is. So what is the component name? That component name is cluster store. Now we say, okay, Rajesh, is it powered by what? MySQL or Oracle or MS SQL or what exactly? Postgre? So none of these. So this is powered by, there's one database which is called etcd. Yes, etcd is one database. Now it's like a MongoDB, you know that, or NoSQL, something like that. Etcd is also one a database, distributed database, which is again developed by CNCF itself. Remember that Kubernetes is developed by CNCF, etcd is also developed by CNCF, and there's so many other products like Prometheus is also developed by CNCF. So many different products has been developed by CNCF. So you have to keep in mind that stuff. In fact, I think you are supposed to go through this session. Oh, I forgot that. What is the name of the tool? So monitoring tool. So that is also developed by CNCF. So now if you want to set up a master server, you have to install the second software, which you have to call it cluster store. Now cluster store is powered by etcd. This is a distributed in a kind of consistent watchable, and this is the source of truth of the cluster. What does that mean? Source of truth for the cluster means whatever you have in the cluster, you will see in the whatever you have in a cluster store, you will see in the cluster. If you don't find in this one, then this is not exist in the cluster. Simple. And if you want to take it a backup of it, you should be have a backup plan for it. So this is the second component which you should be configuring it. How to do that, I'll teach you later. Now,
Okay.
third component which will make the master is controller manager. I repeat, it's not a controller, it's a manager. So manager is doing what? Controller manager is one component, is doing what? So controller manager is the third component. You have to configure, you have to run this component to make the master acting like a master. Now, what exactly this is doing? So controller manager, you can think of is like a monitoring uh, kind of applications, which will, monitor each and everything which is inside a cluster and report back to the API server saying that, hey, this is what I found out. So if I put it in this way, controller manager have a multiple controller, and each controller is monitoring something. Each controller is fetching the data of something. For example, one controller, which you call it a node controller, will keep checking whether the worker node is available or not available or not available. Same way with the endpoint, same with the namespace and all. Okay, so basically you can consider this as like a monitoring solution for the cluster. So which update everyone what should be the right fix for it. Are you able to understand this?
Yes, I am. Did
Okay,
you
and
did
the
you already go in detail about what is the endpoints? I don't think I have an understanding of
endpoints.
endpoints.
When I talk about the service, no, then I'll talk about the endpoints.
Oh, okay.
Okay, so
Okay.
service load balancer. So that's the reason I talked about only node, no endpoint, no namespace, because I need to talk about that.
Okay, understood.
Give me 2 seconds. Yeah. So okay, can you see my screen now?
Again.
Yeah. Now next one is scheduler. So what exactly the scheduler is doing? See, scheduler is scheduling the work, not doing the work. Scheduling the work. So for example, you said, hey API server, give me 10 pod. 10 pod means 10 containers maybe. So give me 10 pods. So API server received that request, stored in a cluster stored, and controller reported back saying that, hey API server, there is no pod as such I found out in the whole cluster. CPS server said will place a request for the scheduler saying that, hey scheduler, can you do one thing? Can you schedule the 10 containers in the different nodes? So now kube scheduler will decide which node to be assigning this work to. Okay, so it's like scheduler is like scheduling the work. Okay, watches API server for the new pod request, and then if there is a request from the API server for the new pod, assign the work to the node, and they have a affinity, anti-affinity constraint and resource limitation as well. So you can influence basically scheduler saying that, hey, assign this pod only to this node or that node. Those are the things you can do that, but right now I'll just skip that part. Okay, so overall in a master server you need to have, in order to make a master as a master, behave like a master, you need to have a 4 software which you need to install it, 4 application which you need to configure it. How to configure it, that's easy things I'll tell you later. But API server, cluster store, etcd, controller manager and scheduler, so these 4 primary software which makes the master. Now did you understand this?
I did.
So this is, we call it a master. So look at her. This is a human body face. So we do have a control. This is also master, right? Control plane, right? So if you want to correlate the API server functionality, which receive all the requests from everywhere, so which part of the which part of her uh, face can act like API server? So it could be ear, right? Ear receive everything, right? Now, what could be the storage? Storage is your brain. That's where you store the data. That's a etcd, cluster store. Who should be acting like a controller manager?
Wait, quick question. So what's the
Hmm.
difference between the the etcd and the kv cluster store. If the etcd is actually storing the key value pairs, and you said that the kv cluster store is responsible for all the information within the cluster.
Right, right.
So how do you differentiate the two?
Which one?
How would you, what is the difference between the etcd and the kv cluster store? How do you differentiate the two?
Though both are same. Both are same.
Okay.
Clustered store is basically one application. Now powered by etcd. Powered means, let's say I'll say, hey, this is my database server. Okay, so database server, but powered by what? MySQL or Oracle or MySQL
Oh,
or Postgre.
it was dependent on kv cluster store.
Yes, yes.
Okay, I get it now.
So now controller manager. So controller manager which look at everything and report back to the API server saying that, hey, this all things is I have seen it. So maybe eyes can act like a controller manager. Now scheduler, who can schedule the work? See, not doing the work, but schedule the work. So who can do that? Mouth. Correct now?
Sure. Okay.
Yeah. So here this look at this face components. This all components coming together, working together in a certain ways. So this face can, I mean, this human can control the everything. So same way you have master server. Make sense?
Right.
So yeah,
Yeah. Follow.
master server we have a four component. One is API server, another is cluster store, third one is scheduler, fourth one is controller manager. So this is called master server. Now look at the node part here. So this is a little bit broader architecture. Slowly we are complicating it. So now you see that here there is a laptop at the bottom. And if you look at it very carefully, laptop has one utility which is called kubectl. So that's your workstation. That is you. You have a laptop, you install kubectl, and then you write your desire in a JSON format. And then you send to the API server. API server stored that information in cluster store. Controller manager said, hey, this is what I have seen it. Any mismatch, API server informed the scheduler, hey, scheduler, go and schedule the work to the node. And node you have a pod, and inside a pod you have a container, and that is how the whole infrastructure application you can deploy. Are you understanding?
Yeah, I do.
Now let's focus on the node part. So now you have understood that four components you need to configure in order to make the master. And also you understood that workstation, which you have a kubectl installed, which will make a connection to which will make a request to the API server. Now let's focus on the worker. So what we have in the worker? So we call it worker as a we sometimes we call it a worker, sometimes we call it a node, sometimes we call it a minions. It's up to you. Worker is a official terminology. So the question is, how do you make the worker worker? That's the question. How do you make the worker worker, behave like a worker? So in order to make the worker worker that behave like a worker, the worker need to have one agent installed. Each worker must be having one agent installed. What we call it, this agent? This agent we call it a kubelet. That means if you want to set up a worker, you need to install the kubelet, you have to configure the kubelet, and kubelet should always talk to API server. Okay, so that's the first component of each worker, kubelet, which is a main Kubernetes agent, and this agent only register the node with the cluster. Cluster means API server to create a cluster, and kubelet keep watching the API server all the time. Okay, keep connecting that API server and sharing the information. And now kubelet only instantiate a pod. Yes, if someone will ask you, hey, who create a container? So
The
what do you
kubelet.
answer? You no Docker. Docker.
Doc, Docker. Okay.
Docker container is created by Docker, and
I thought
container
that
you have in the pod. Look at this. So container is created by Docker,
my
but
question
container
was,
in but in Kubernetes you keep the container inside a pod. So who's creating pod? So pod is instantiated by kubelet. So it's like this. Kubelet instantiate a pod and then ask Docker, hey Docker, I have instantiated a pod, please fill the container inside it. Okay, so it's like that.
yeah.
So
Okay.
kubelet is
Thank,
important.
with the new versions of Kubernetes don't actually account for Docker anymore. I think they actually removed the dependencies. So how do you work around that?
Which one?
With the new versions of Kubernetes, they have actually removed the dependencies on Docker, I believe. So how would you actually, would you say it makes a difference?
That's a very good question, but actually you need to understand a little bit deep dive into the containerization. So see here, earlier, the old architecture I'll tell you. So the old architecture was like this. You are this human and you send the command to Docker client. Docker client sends this command to Docker server, Docker daemon. And Docker server sends this command to container D. This is a utility. And then container D talk to the kernel to create a container. This is something which used to happen in the old Kubernetes 1.22. Okay, 1.22. But you know what? Until the 1.22. So from 1.23, what they did, this human means in terms of Kubernetes will become a kubelet. Okay.
Yeah,
See.
understand.
Yeah. So now in this later version, what has happened? They have this one. So still you have a container D. Okay. Make sense?
Yeah, somewhat.
Yeah. So this medium, because this only request that. So but still Docker is required. Then you'll say why? So remember that there is a one process called downloading image and there's a creating container. That's a two different process. So downloading image still you have a need a Docker, and for creating container you just need container D. That's all. So still you need in the latest version also, though it's not been used, but still you need to download this Docker.
Okay, makes
Got it?
sense.
Yeah.
Yeah.
Okay, so this is a kubelet, which is agent, which has to be run in each worker, and the port is on which is running 10255. Okay, 10255. So now what is the next component? Container engine. So here it can be anything. So if you know like a Docker, it can be Rocket also. It can be container D right now, which is a container D now itself. And this container engine will help you to create a container and pull the images and stuff like that. Now third component which has to be there in your environment, that has to be kubeproxy. So kubeproxy has to be installed, and because of this kubeproxy only, you are able to run multiple container of Apache in form of pod in a same host, and you're able to access from outside also. Why? Because you know what? That's one interesting thing. In a Docker world, container get IP address, but in Kubernetes world, container do not get IP address. Pod gets IP address. I
Okay.
repeat, in the Kubernetes world, pod get IP address, and let's say if you have a two container inside a pod, then you can access both the containers using the same IP address.
Oh,
Okay.
because they'll be assigned on ports.
Yeah. So this is the networking services of Kubernetes. That component we call it proxy. So I'll just skip some of the stuff. So in the worker, what you need to be having, so that worker will behave like a worker. So worker should be having kubelet, container engine, and kubeproxy. So if you configure these three tools together, configuration is a different part. I'll talk about it. Then worker will behave like a worker. So now look at this, how this master and worker talk to each other. Look at this. Master, you have API server, controller manager, scheduler, and cluster store. And now if you look at this internal arrow I have shown you in the last slides, look at this here. Kubelet keep talking to API server, and the same way your networking services, which is a kubeproxy, keep talking to API server again. Are you understanding?
Yeah, I do.
Yeah. So kubelet, kubeproxy, and container runtime. There are few more add-ons are there. Right now, not discussing because it's not important for running the cluster. So like a DNS, ingress, and dashboard. Okay, so this is the image. Look at this very carefully. and build the whole perspective of architecture. Very important one for working with the Kubernetes. So see here, you can make a request through the command line and UI dashboard we have it, and all the requests go to the API server, and then scheduler and controller manager in TCT, and then you scheduler talk to the API server also this worker, different worker. You look at this different worker. You have a Docker, kubelet, kubeproxy, and multiple pods you have it. And each pod, if you look at the containers, maybe 1 or 2 or 3, whatever it is. So this is the overall architecture of Kubernetes.
Okay.
Now, this is a one more architecture, but I'll just skip it because too many things you will get confused. So yeah, so now you understood this whole overall architecture. So remember that in a Kubernetes cluster you have a master, you have a worker, and you have a workstation. Last one, kubectl. So in a workstation you should have a kubectl, and in the master you have a API server, scheduler, controller, and control manager, and cluster stored etcd. And worker you have a kubelet, Docker, and kubeproxy. Make sense?
Yeah, that does.
Okay, so now what we did is we try to understand what is Docker. First question, why do we need it? Second question, and how Docker works. I'm sorry. Kubernetes. What is Kubernetes? First question. Second question, why we need it? Why we need the Kubernetes? And then how Kubernetes works? Kubernetes architecture. So these are the three questions we try to discuss this one. And now after that we'll learn what you want to, what you should ask for it. So second topic which we'll discuss, like we'll set up a cluster, master, worker, and everything. And then after that I'll teach you how to demand different API resources from the Kubernetes. For example, when I ask you to learn AWS, you say, okay, I need to have VM, I need to have VPC, I need to have a EBS, I need to have EFS, I need to have a S3, I need to have IAM, all these things, right? You demand those services from AWS. So same way, once we set up a Kubernetes, you can demand a pod, a replication controller, service, deployment, ingress, PB, PBC, and so many API resources, which I'll discuss one by one. Are you understanding?
Okay. Yeah, I do.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.